AI research creates a unique risk when it generates highly plausible, perfectly formatted reports that no one verifies. Large language models prioritize narrative coherence. They are designed to produce text that flows logically from one sentence to the next, which is not the same thing as being factually accurate. The model discards opposing facts simply to maintain that narrative flow, ignoring their actual accuracy. Evidence that contradicts the building story is downweighted because it disrupts the coherence of the report. This creates the search illusion. The output reads exactly like rigorous, data-driven research, but it is actually a convincing story masquerading as data. Context can make this problem worse. When a research pipeline feeds on its own previous reports to establish context, it creates a closed-loop echo chamber. The MET-META benchmark, a test of how AI synthesizes medical meta-analyses, proves this. Models consistently fail to reject logically faulty evidence if that evidence aligns with their initial assumptions. The model treats alignment with its prior beliefs as a proxy for truth. It accepts anything that fits the narrative and deflects conflicting information. Feeding AI outputs back into an autonomous system fails to make it smarter. Instead, it amplifies survivorship bias and hard codes existing prejudices into the logic. Instructing an AI to be objective achieves nothing. Behavioral prompts fail because the bias is built into the generation process itself. Defense must be structural. One effective architectural defense is counterfactual filtering. This uses inverse hypothesis generation. The system takes a search query and automatically branches into a second, opposing search path, forcing the retrieval of conflicting data sources. Then, diversity-aware retrieval applies a mathematical penalty to search results that are too similar. This prevents the model from returning a stack of sources that all parrot the same claim. We cannot trust a model to look for counter-evidence on its own. We must build pipelines that force it to confront its own blind spots. A major flaw in current AI research is letting a single model review its own work. The team of rivals architecture solves this by enforcing a strict separation between the agent that generates the research and the agent that validates it. Using atomic claim abstraction, the narrative flow is systematically dismantled into isolated factual assertions. The isolated critic agent evaluates these claims with unilateral veto authority. It rejects false positives independently, ensuring rhetorical style cannot hide logical errors. Destroying the narrative and separating agents prevents smooth writing from camouflaging factual decay. While this architectural overhead demands significantly more computing power, the result is a massive and measurable increase in overall accuracy. Standard single-agent verification only resolves factual errors 60% of the time. Adding external web search tools for citation checking improves that rate to 75%. But the team of rivals architecture pushes error resolution to 92%. These multi-agent systems require roughly triple the compute cost, but a massive 32% leap in accuracy is the necessary price for research that informs high-stakes decisions. Even a 92% accurate pipeline can fail if the human user provides a poorly designed task. This is the parity trap. It happens when you give a model a pre-digested conclusion and ask it to verify that conclusion is correct. If the answer is already implied in the prompt, the model's reasoning engine never activates. It simply summarizes what it was already handed. To get real reasoning, we must follow one rule: construct, never verify. Users should strip away all analyst commentary and provide only raw data and constraints. This forces the model to build the analysis from scratch. To extract truth from artificial intelligence, we cannot simply ask it to be honest. We must build architectures that structurally distrust it.